Hello everyone, it's a new day, so we are still on access control list. So today, as you can see with this topology, we have multiple VLANs in here. So we want to filter traffic between these VLANs. Okay, I know that you guys noticed that with the ACL lab that we did, we were only able to filter traffic intra-VLAN, meaning within a specific VLAN. But then what if you have multiple VLANs and you still wish to filter traffic? What do you do? Right, so that is what this lab is all about. But then one thing you should know is that VACL was designed specifically to filter traffic within a VLAN. So for instance, if you have this server farm which is on VLAN 100, perhaps want to filter traffic between server 1 and server 2, we'll use VACL. Is that okay? But here lies the case that we have multiple VLANs and VACL wasn't designed for that. So I'm just going to teach you how to do it. Right, so let me just explain the topology here. So we have VLAN 100, which is the server farm. Then we have VLAN 10 for the IT department, VLAN 20 for the human resource or HR department. Then we have our our access switches, switch 1, 2 to 3. That's our access switches, which interconnect these devices in their respective VLANs. Then we have our distribution switch, which is the inter switch, which will be doing the inter-VLAN routing. So to get this topology working, you obviously need to set up your trunk links. Okay, these links you see here, you need to set up your trunk links. Then you configure your access switches, your access links, to make sure that these devices are put into their respective VLANs. Then just do basic configuration, IP addressing and all that, and the VLAN configurations. Right, so let's start with today's lesson. Okay, so this is the lab you are going to be performing. So we are going to be creating an access list for the IT department as well as for the HR department. Okay, so let's begin with the IT department. So as you can see here, we have two devices in our IT department. We have the boss's device as well as a device for interns. Okay, so we are assuming that this PC has been allocated for interns who work with the company. So since they are interns, we need to restrict certain access that they have on the system as well as with respect to other departments. So we like to first prevent the entire IT department here from communicating with the HR department. Okay, so we don't want any device connected to VLAN 10 or devices within the IT department to have any form of access or communication with devices in the HR department. Is that okay? Then the next task is to then deny the intern. Okay, you need to deny this intern who is in the IT department from having access to these services, SSH, Telnet, HTTP and TFTP session, okay, to server 1. Right, so we don't want this intern to open an SSH, Telnet or HTTP session to this server 1. So we are assuming that this server is basically for probably the head of IT, who is the boss. Contains probably some sensitive information that only the boss should have full administrative access to. So we need to restrict the intern from having these services, connecting to these services. Right now, we are also, so after that we should then allow full access to server 2. So the intern should then have full access to what? To server 2 here. Right, so let's start implementing that. Okay, so let's access global configuration. All right, so let's create our access list. So we have to prevent the entire IT subnet from communicating with the HR department. Okay, so we are going to be using extended access list. Okay, and we give it a name. So IT ACL, right? So now let's deny this entire subnet. So deny IP. Okay, we want to deny all form of IP communication. Okay, so we are going to be denying IP. So deny IP. The next thing is to state the source address. Now you notice that we want to prevent this entire subnet, not just a specific device or specific devices within the subnet. Okay, so to achieve that, we know that VLAN 10 network has an IP of, the network ID is 10.1.10.0/24. okay, so 10.1.10.0. okay, then we use the word card mask 255. So what this basically means is that wherever there's a 0 means that there's a match. So the final digit could be anything, but the 10, 1, 10 here should be a perfect match. So irrespective of whatever is here, when the access controllers finds a match with these three, it doesn't matter what this final figure is, they should drop it. Is that okay? Right. Now we need to define a source. Okay, a destination address source. Now since we don't want it to have access to devices within VLAN 20, basically means that we need to prevent it from also accessing that entire subnet. So the HR department has a network ID of 10.1.20.0. so it's basically the same thing, 0.0.0.0.255. is that okay? So we are done. Right, so we are done preventing the IT department from communicating with the HR department. Now the next thing for us to do is to issue the permit IP any. This is very important, so as to override the implicit deny rule, which restricts any form of communication with devices outside like over the switch, whether inbound or outbound. Okay, so when we use this permit any IP any, our devices here will be able to communicate with server 1 and server 2. Even though we've only restricted access to VLAN 20, due to the implicit deny all rule, we still wouldn't be able to communicate with these VLANs or any other VLAN. But once we issue this command permit IP any, you should be able to have communication to other devices. Right, so the next thing for us to do is to apply the ACL. Okay, but let's check our ACL first. So do show access list. Okay, so this is the access list we've created, ACL. So our first sequence 10 is to deny any device within the subnet from accessing devices within the subnet, which is the IT subnet. And then we have our permit IP any, which overrides the implicit deny all rule. So now let's apply it. Now to apply this, normally I'm pretty sure you guys will be thinking that we should apply it to this interface gigabit 0/2. No, remember we are working with VLANs here, and we've created XVIs to perform inter-VLAN routing. So let's confirm that. So do show IP interface brief. So as consider, these are the respective SVIs for the various VLANs that we have here. So these are basically the gateways that these devices use to intercommunicate with each other. And this is the VLAN 10 SVI IP, which is a 10.1.10.254. okay, so since this is for the IT department, we need to apply to this particular VLAN, which is VLAN 10. okay, so we need to access that VLAN, the SVI interface VLAN 10. Then we use IP access group. Then we need to type in what the name. Okay, the name that we use what? ITACL, as you see here, ITACL. So ITACL, and then we ask to define which way to bind it, whether inbound or outbound. So as best practice, you need to, when it comes to extended access list, you need to always bind it as close as possible to the source. Is that okay? So we need to apply this inbound. Is that okay? So we'll apply it inbound, and we are done. So let's confirm to be sure that that's okay. I'm pretty sure that's it. So now let's confirm to show that our access list is working now. So let's access the intern's PC. Okay, now PC1 here and PC2 are both in the HR department. Let's check out their IP address. Okay, show IP. Okay, so PC1 has an IP address of 10.1.20.1, whilst PC2 here, show IP interface brief, has an IP address of 10.1.20.2. Is that okay? So let's see if our intern here can ping 10.1.20.1. Destination is what? Destination is unreachable. It's unable to what? To reach it. To make connection. So now let's see if we can ping to. It is also what? Unreachable. Right, now let's check to find out if our boss here is able to ping any of the PCs in there. So ping 10.1.20.1. Okay, success rate is 0. It is unable to ping it. Now let's see if it can ping 20.2. Our pings are failing. Success rate 0%. Our pings failed. So it means that everything is working. So let's do a Wireshark capture so that you see it for yourself, how this traffic is flowing within the network. Right, so let's see. Okay, so let's filter for ICMP traffic. So now I'm going to ping PC1 from the boss's PC. So right, let's see our output. As you can see here, there's an echo request. Okay, but then the destination is what? Unreachable. Why is it unreachable? Because the communication has been administratively what? Filtered. Is that okay? So it means that our ACL is working. So but notice something. Let's remove that particular you see we applied it to the VLAN, right? Let's remove it and see what happens. Okay, so no IP access group IT ACL. Okay, so we've removed even though we applied it, we've not removed it, so it is not bound to any particular VLAN. So let's see if our boss can now ping PC1. Yes, success rate. Now let's see if we can ping PC2, which is in the HR department as well. Perfect. Now let's see if our intern here is able to also ping the HR. Yes, the pings are working. Right, now let's see if he's able to ping the device 2 as well. Okay, so we lost one packet due to app, but everything is working perfectly. Right, so now let's apply it, because that is our task. We have to prevent this VLAN 10 here, the IT, from communicating with HR. So let's apply it. Okay, now that's it. Cool, we are done with that part. Now what's the next thing to do? The next thing to do is to deny the intern in the IT department from opening an SSH, Telnet, HTTP and also TFTP session to server 1. So for now we are going to test want to find out if it is true that this PC here can actually do all these. Okay, so let's first test to see if the intern can SSH to server 1. So for now, let's check the IP address of server 1. So server 1 has an IP address of 192.168.10.1.1. okay, so now let's access our intern's PC. So we just open party, right? Then let's create a new session. So we want to SSH into 192.168.1.1. okay, so we know that SSH is on what? Is on port 22, right? So let's create the session. Okay, so let's check the credentials first. Need to know which credentials to access this thing with. So show RAM pipe include username. Sorry. Okay, so that's a username of Vegas, then a secret of, I think I used Cisco. Yes, I did use Cisco. So let's try it and see. So Vegas password of Cisco. Yes, I mean, so the intern is able to SSH. Now let's see if the intern was able to telnet as well to the same IP 192.168.1.1.1. okay, right? So we know that SSH uses telnet uses a port of what? 23. okay, you can either tap it in there or you just select telnet here. It's still the same thing, which is 23. So let's create session to server 1. It says invalid host name. Let's recheck that. Delete. Okay, so 192.168.1.1. okay, so we want to telnet. That's great. Okay, we are in. So Vegas password of Cisco, right? Okay, so basically this intern has quite a lot of power. Can SSH to these servers and wreak havoc, do whatever it wants to do in there. And also let's see if it can open an HTTP session, maybe a web GUI. So we are assuming maybe the intern here doesn't have that much knowledge regarding SSH or telnet, but wants to use the GUI, which is the graphical user interface, to configure the server. So we definitely open that. So let's see if the intern is able to do that. So we'll open our web browser. Okay, so I've enabled HTTP as well as HTTPS on the server. So it's actually these devices are actually routers. Okay, I only changed their icon or their symbol to make them look like servers. Okay, so as to help you guys understand. So yes, have that mindset that these are actually servers. Okay, but then they are actually what? Routers. Okay, so let's okay. Okay, took quite a while for it to load, but we are in. Okay, so now let's type in, so HTTP, okay, 192.168.1.1. Wow, my RAM is really firing up, processor is also firing up, right? Okay, so let's enter our credentials. Cisco. Okay, so we are in. So the intern has been able to access the GUI, the graphical user interface of the router, and can perform certain configurations on it via the GUI. Okay, so let's quickly apply our ACLs so that we don't waste much time on this. Right, so let's access our ACL. So IP access list extended IT ACL. Okay, so now we are going to deny SSH traffic. Okay, so deny, we know SSH is uses TCP port 22. Okay, so right, so this time around, instead of restricting the entire subnet, we're going to restrict just a single device from opening an SSH session. Okay, so use the command host, and we'll type in the IP address of the intern's PC, which is 10.1.10.2. okay, and since we are restricting it to a specific device to within another VLAN, which is this one, we need to use the command host. Okay, and we know server 1 uses an IP address of 192.168.1.1. okay, right, so we want a specific, so use either EQ. And now notice that with these ones, with these outputs you see here, you are not going to find SSH in here. Is that okay? But don't panic, since we know the port number for SSH, we know that SSH uses a TCP port number of 22. You just type it in there and it should work. Is that okay? Now the next thing is to prevent telnet. You know telnet also uses TCP. So we can either type in here telnet, the word, or we'll use telnet port, telnet TCP port 23. Okay, so just type in 23. So we've denied telnet as well. The next thing is to deny HTTP. You know that HTTP too, we can use either www here, or we can use port 80. Okay, so port 80 has been denied. You also need to deny TFTP. Now we know that TFTP uses a UDP port of 69. Okay, so we'll need to enter UDP, so host 10.1.10. okay, all right, host 192.168.1.1 UQ. So let's confirm if TFTP actually uses port number of 69. Yes, use a port number of 69. So we just input 69 in there. Right, so we are done. We've satisfied all these parameters where we are to deny traffic from this. But the next thing is to allow it to have full access to server 2. Okay, so let's add that. So permit IP from host, okay, 10.1.10.2 to host 192.168.1.2. 1.2 here is the IP address of server 2. Okay, so we are permitting all IP traffic to server 2. We are done. Okay, but let's check our ACL. So do show access list. I want you guys to notice something. You know, I'm pretty sure from now you should know that access control list processes its entries based on the sequence numbers. Okay, process it from the lowest sequence number to the highest one. Okay, and as you can see here, our first entry is to deny any form of IP traffic to the HR department, which has been satisfied. Okay, now moving here, we are also to permit any form of traffic, any. Now, since we have this command here, permit any, as the second sequence, it means that all these wouldn't be processed. So it's like basically if allowed any form of IP traffic to go anywhere within different subnets or different VLANs. So all this hard work we've done here wouldn't work. So we need to resequence this particular entry to come to the bottom to last. Okay, so let's remove this particular entry and bring it below. Okay, so that it becomes the last entry within this access list. Okay, so to do that, we first need to access the access list. So IP access list extended IT the ACL, right. Now there are two ways for you to remove this particular entry. So you either remove it by using the no command and then either copying and pasting the entry itself. That is, let's say permit IP any. So once I execute this command, this particular entry will be removed. A much better way of doing this is by removing this entry using the sequence numbers. Okay, so these sequence numbers you see here uniquely identifies each particular entry. So for instance, if I wish to remove this entry, I could just use the command no 20, which is much better. So you notice that, so do show IP access list. So you notice that it's gone. We now have from 10, 30, 40, 50 and 60. So now let's add that entry back again. So permit IP any. So notice that it has now been issued a sequence number of 70 and it's now right underneath. Okay, so let's test connectivity. Let's see if our intern here is able to SSH to server 1. So let's delete this whole session and create a new one just to make sure everything is working fine. So 192.168.1.1. okay, so SSH create. Okay, the fact that it's taking too long is telling me that it is unable to establish the connection. Let's open the telnet connection as well, 192.168.1.1. select telnet. So notice that we are unable to connect. We are unable to SSH to server 1. Let's try telnet on port 23 as well. It's also going to time out and wouldn't be able to connect. Right, so it means that our control list is working perfectly. Now let's see if it will be able to open an HTTP session as well. So let's type so yeah, okay, so let's see, ask for your name, Cisco 192.168.1. did we, oh okay, seems we forgot to we forgot to add an entry for HTTP, so the intern is able to do that. So let's work on that. So IP access list extended ACL. Now notice this, if the moment we create an entry to deny access for HTTP, then also for HTTP, it is going to come right underneath this particular entry. So to give in a sequence number of 80, and we don't want that to happen, so we are going to put it here in between these two entries and issue a sequence number of 20 for it. Is that okay? So let's do that. So you use this command, so you can start with the sequence number. Okay, you want to issue the sequence number of 20. Okay, and then we can go on to issue to add our entry. So deny HTTP, right? Okay, so deny host 10.1.10.2, right to host 192.168.1.1 equal to what, 80. We know that HTTP is on TCP port 80, so that works perfectly. So let's check. So do show IP access list. So we'll notice that instead of our entry here coming underneath here, because we issued we assigned as a sequence number to it, it is now the second line of entry here, right? So now let's try to SSH. Where is it? See if we are able to SSH. Okay, that was it. Okay, I believe this is it, 192.168.1.1. Okay, let's see what telnet timed out. Okay, everything works perfectly. Okay, so our web here would also time out. So in case maybe it tries to open a TFTP session to maybe copy a file or transfer a file or all that wouldn't work, right? So we are done with ACL. See, it timed out, right? Everything works perfectly. So I believe we are done with the access control is for the ACL. Now let's quickly move on to the HR department. Okay, so we don't want the HR department from communicating with IT. I know some of you will be asking as to why we have to add this particular entry where we already have an entry in the ACL which prevents the IT department from communicating with VLAN 20. Now you should know that this particular ACL was configured for VLAN 10. Is that okay? For devices in VLAN 10 and not for devices in VLAN 20. So notice something. Let's send a ping from PC1 to, let's say, the boss PC. And notice something. I want you guys to notice something here. So you are going to send a traffic. Let us do a Wireshark capture on this link here. I want you guys to see why it's important to do it on both sides, right? So let's filter for ICMP traffic. Okay, let's filter for IPMC traffic, the ICMP traffic, right? So from PC1 we are going to ping the boss PC, which uses 10.1.10.1. okay, notice something. So realize that only echo request messages are being sent. As you've noticed, only echo request messages are being sent but then no response has been what seen. Like it says, no response seen to the ccnp what request. So what this means is that the PCs here, they haven't been filtered in any way not to send traffic to device in VLAN 10. They are allowed to send traffic to devices in VLAN 10 here, but due to the ACL entry that we configured on VLAN 10 here to not send any traffic to devices here, they are unable to send a reply to the request. So you notice that device in VLAN 10 are receiving an echo request, all right, but they are unable to reply because the moment it gets here, that traffic is filtered. Now let's prove that theory. Let's see if what I'm saying is actually true. We are going to issue the same ping again, and I want you guys to just see what happens. Let's filter for ccnp traffic. Okay, right, see, we are sending the same traffic from PC1 to the boss PC. Notice this. So as you see here, it received an echo request, okay, from what? From the source device, which is PC1 in VLAN 20. Okay, now it sent a reply 10.1.1.10. okay, it sent an echo reply, but then due to the ACL we configured, it was what? It was filtered. So communication administratively what? Filtered, as you can see. So basically the traffic got to the boss PC. The boss PC issued what? A reply, but once it got to here, it was what? That traffic was filtered. So devices here are unable to receive the reply, but they can still send traffic. But we don't want that to happen. We don't want this HR department to be able to send any form of traffic to devices here. Is that okay? That is why we need to also issue this command within this VLAN for these devices here in the VLAN. Okay, right. So we are going to create a new access list. Okay, and this time for the HR department. Okay, right. So IP access list extended HR ACL. Okay, so we are going to deny all form of IP traffic from 10.1.20.0, so from this subnet to 10.1.10, okay, which is basically VLAN VLAN 10 0.255, right? Okay, just hit our enter, we are good to go. Right, so the next thing that we are supposed to do is to then allow HR full access to server 2. Okay, so we have to allow HR to be able to send IP traffic, unrestricted IP traffic to server 2, right? So permit IP for, so you notice that this time round we are giving full access to all devices within the HR department and not a specific device or specific devices. So we will not use hosts. Okay, we are going to be using, we need to allow the entire subnet access 0.0.0.255. okay, but then we are only allowing it to have that access to only server 2. Okay, so this time around we use the host So 192.168.1.2. So what this command means is that we are permitting all devices within subnet 20 or from the HR department to be able to send any form of IP traffic to server 2, which is this host. So that satisfies this task. The third one is to allow the HR department to send only FTP traffic to server 1. Okay, so basically we are going to allow, permit what? FTP. So we know FTP uses what? TCP. So let's check it out. So 10.1.20.0.255 to host, this time to what? To server 1. Okay, so 192.168.1.1 equal. So it says that we have to allow FTP. Okay, so we know that FTP uses the TCP port number 21. So we type in either 21 or FTP, any works. So 21. Okay, we are good to go. Right, so this satisfies the entry that we have here. Okay, so we have our entries. So notice this command with our third task is a bit complicated in the sense that you see we are allowing HR to send only FTP traffic to server 1. Okay, so we've issued this command in here which satisfies that task. But normally you would want to add this particular entry like permit IP any, but then that would nullify this command, this particular entry, in a sense that we want only FTP connections to be sent from the HR department to server 1. But if we were to add this entry here, that means that any other traffic, regardless whether ICMP, SSH, TFTP or whatever, can still be sent from these devices in the HR department to server 1. So that is why we ended our entry list on this one on sequence 30, and that satisfies it. So now let's test this theory to see. So let's assume PC1 wants to ping server 1. For now, it is unable to send any traffic, or it shouldn't be able to send any traffic aside FTP to server 1. So let's try to ping it. So let's ping 192.168.1.1. See, says that communication is what? It's prohibited, right? So we are unable to do that. So now let's test on PC2 as well. So ping 192.168.1.1. Our pings are failing, they are being filtered out. Let's try to telnet. So telnet to 192.168.1.1. it says that what? Destination unreachable, gateway or host is down. That's because that traffic has been filtered. The same way if you try to SSH to 192.168.1.1, you're also going to get the same one. It means everything is working. So if we try to TFTP to server 1, it should work perfectly. So guys, that is how you configure ACL or set up access control list in an Inter-VLAN environment. So just like I mentioned earlier on, VACL, that VLAN access control list, was designed specifically to filter traffic within a specific VLAN or within specific VLANs. Okay, it wasn't designed to filter traffic between multiple VLANs. So in order to do that, if you have multiple VLANs and you want to configure, or maybe you have some sort of segmentation within your topology or network, you do it this way that I've demonstrated to you. Okay, so guys, if you like the video, kindly subscribe and also like the video as well, as because this helps the YouTube algorithm to be able to feature my videos on the top list so people can find it and also learn. And also don't forget to subscribe to the channel. Thank you very much. Have a good day.